Right? So I go up here, it's in degrees, so I'm going to go 30 times pi on 180. And, you can either simplify 30 on 180, which is a very easy thing to simplify, or you can type it in your calculator and allow your calculator to simplify for you. Okay, and that's pi on 6. So it's one we know. It's one of our good ones. Yeah. It doesn't matter. I'm just multiplying. Right, so radians and degrees don't magically change everything. They only change like tan of something. Right, I'm just multiplying. Your calculator's not going to multiply differently when you're in radians or degrees. It's not going to do anything differently. The only thing you need it for is when you go sine of something, and it has to know if it's in. Yeah. Because that's what I have. So 30 times pi, 181. Yeah, right? Okay. All right. Then B says convert to degrees. So I have 4 pi on 3. I'm not writing that symbol, sorry. And then I'm going to multiply that by 180 on pi. You'll know you're doing the right thing because the pi's will go away. And I'm trying to get the pi's away because I want it to be degrees. And I'll either type it into my calculator or I'll go, okay, well, that goes in there 60, so that's 240. And I'll put my degree symbol now. But you can easily type that in if you are a fraction phobe. Okay, now C. Now it's going to matter because I'm going to do that. And I have to have my calculator in the right mode. So it's convert pi on 4 to degree measure and hence state the value of sine pi on 4. Do you know what the degree measure of pi on 4 is? Okay. I don't know why I thought you would know that, but that's all right. So let's go here and do pi on 4 times by 180 over pi. Pi's cross 8 out. And how many times does 4 go into 180? Yep. And you know what the sine of 45 degrees is. Because it's in your noties. And you're going to memorize it. 1 over the square root of 2. I hope you remember from year 7 or 8. I think in year 7, you did a report where you had to find out all the house color people in your house, and then you made a pie chart. Remember that with the colors in it? You don't remember back that far. Okay. But here's how it works. It says that, the circumference of a whole circle, is pi times diameter, or we could say 2 times the radius times pi. Is that right? 2 times the radius and the diameter are the same thing. So that's a formula, which I do think is on your formula sheet. So that's the circumference of the entire circle, all the way around. So if I know the radius, I can know the circumference. So if I want just the arc length, I need to do that, just this fraction that I have. They call that a minor arc because it's just from an acute angle in the center. And to find the minor arc, I'll do however big that angle is over 360, because that's the degrees in a circle. So that's the fraction of the circle I have, and then I'll multiply it times that. Okay, so that's how I do that. Now, if I'm in radians, it's fantastic. So if theta, same picture, I'm doing this picture for both. If theta is in radians, super easy, because I can just multiply the radius times theta. So I don't have to do this fraction nonsense, blah, blah, blah. Okay, it's just theta times radius. So when I'm in radians, it's really so much easier to find arc length. And in your book, they're going to say, change to radians and then find the arc length. Okay? Do you have to? Can you use this? You can use it. Nobody cares. Do you understand it? Do you understand what I'm finding? How long this thing is? Okay. Now, sometimes they're going to ask you to find a major arc, and that's like on the other side. You know what I mean? It's on the big side. So sometimes they'll ask you for that. And to find that, of course, you're just going to take whatever this angle is and subtract it from 360, and then you'll have the angle, okay? Or from, what do you reckon 360 is in radians? 180 is pi. Yeah, and so 360 is 2 pi if you need it. Okay, nice. Okay, good. Then the area, same. The area of a circle is pi r squared. And so the area, same way. This is the way we learned when we were little kids, that we did theta over 360 times pi r squared. And that gave us the area inside here, or the area of this big thing. But if I'm using radians, then I do 1/2 r squared theta. Okay, so these formulas are kind of helpful. Don't know if they're in your formula sheet. I don't really have one out. I don't know. Could be. All right, let's do these two examples. These are right in front of you, so I'm going to put them underneath here, okay? All right, an arc subtends. Subtends is this thing. It cuts, right? Subtends mean it cuts the circle, okay? An arc subtends an angle of 56 degrees at the center of a circle. I'm going to draw a little thing, and this means an arc subtends, and this is 56 degrees, okay? And the radius of the circle is 10 centimeters. Calculate the arc length, the length of the arc, to 2 decimal places. Okay, I'm going to turn 56 degrees into radians. Okay? I don't have to, but I want to. So I'm going to go, all right, that angle, 56 degrees, times pi on 180, gives me radians. And I'm doing 2 decimal places, so I don't have to worry if it's yucky. Okay, so I'm going to do 56 times pi on 180. I'm going to do 4 decimal places to start with. For that angle. Okay, that's how many radians. Does it make sense that it's 0.9774? 56 degrees is less than 60 degrees, so it's less than 1 radian. Right? Okay, so it's there. So that's where I am. Okay? All right. So there it is. And it says calculate the length of the arc. So I write it like this. I write length equals r theta. So length equals 10 times 0.9774. Where did I get that formula? I got it up there. Radius times theta. So it's equal to 9.2 decimal places, 77 centimeters. Okay, so in these problems, I would turn this into a radian, and then I would just multiply it by the radius. Is that okay? All right, B. Question? So take a note for yourself if you need to. Change to radians, then use the formula. Okay. It says calculate in degrees the magnitude, that just means size, okay, of the angle that an arc of length 20 pi centimeters subtends at the center of a circle of radius 15. Okay, so here I go. Same. I don't know what the degrees are. Calculate in degrees the magnitude of this angle. The arc here, the length of the arc, is 20 pi. And the radius is 15. So I'm going to use my formula up here. L equals r theta. I know the L, it's 20 pi. And I know the radius is 15, so I'm solving for theta. What do I do? Pi? Okay, so 20 pi divided by 15. Now, when I use these formulas, I want to say it really loudly so you listen to me. When I'm using this formula, I'm in radians. Okay, so I can't just slap a degree sign on there. I'm going to put it like that. I can't just slap a degree sign on there. That's not how it works. It's in radians. How do you convert? Because they want it in degrees, don't they? How do you convert radians to degrees? Times by 180 over pi. So I go 4.1888 times by 180 over pi. So I'm going to do that on my calculator. I'm going to go times 180 over pi. It's like the longest